Hello there. I thought I would make a short Zoom video for us to look at to accomplish two more steps in our explorations with RStudio. The first thing we're going to do is to take a data set that we have on our computer and put it up onto the cloud so we can analyze it in RStudio Cloud. So what I have here is a file that contains the data from figure 8.3 in the book. Actually, the people who published this article made the data publicly available. And you can see, make it a little bit large here, that I have a variable called meet, which deals with where did you meet. One is that you met online, and two is that you met offline, and a general satisfaction measure. And this first data set contains the variables in the first row, and it continues for quite some time. As a matter of fact, if we ride the elevator down here, we have several thousand observations that were presented in this data set. Now, this file sits somewhere on your computer. In this case, I have put it in the directory for this class that I have in my computer here. In your computers, when you receive a file, probably, and you download that file, it's probably going to end up in some kind of a downloads file. And here, for example, you can see SDO1, which is the full data set that Cassiopo et al. Had put in, published along with their article. Coming back to RStudio Cloud, what we now need to do is to send that file from our computer up into the cloud. And the way we'll do that is to come downstairs here to the lower right-hand corner, and you'll see a tab labeled Upload. You can click on that, and then you'll see it's going to upload into our project, and we need to choose the file that we want. So in this particular case, it's going to go to the file where I've saved the data. And now that I've chosen that, I can hit OK, and you'll see that it's uploading the file. When it's done doing that, I'm going to see it appear downstairs here in the directory for this project. And lo and behold, down here it is. So what we've done is we've sent this Excel file to RStudio Cloud. Now, R can't say, oh, this Excel file, it must be a data set. We have to go through the additional step of importing this Excel file into R so that we can actually analyze it. So to do that, we come up to the upper right-hand corner for our environment, say import the data set, and you'll see a number of options. You can read in SPSS data sets, SAS data sets, those are my two favorites, but we have an Excel data set here that we want to read in. Clicking on that, it then wants us to come in and look at the file. And in order to find that file, I'll click on the Browse button, and it will show me everything inside the directory that I have. And I'll select 8.3, and we'll open that file. That takes not too long, and you'll see that we have our two variables here. It tells us what they are, the labels for the variables. And if everything sort of looks the way it should, that the first row contains some names, and I want to view the data when I have, I can then come down here to the lower right-hand corner and click the import button. And this will now give me a view of this data file. And you'll see over here, I have now 16,383 observations with two variables. This is a data set I can now analyze inside of R. So if I'm done looking at my data, I can X out of that And I can turn now to this little program that I'm giving you, which is examples of making some code. So this first line is going to let me see some basic peeks at the data as we talked about before. Tells me the structure. This next line takes the data set. I have 16,000 observations here. If I want to make a plot, such as what you see in the book, or at least analogous to that, I don't want to have all 16,000. It would get really, really dark. Plots would be going everywhere. So what this code does, and you don't have to know anything other than here's something I can maybe steal if I want to in the future. I'm going to make a sample of 500 observations in this data set. So let's spend a little bit of time saying my sample, that's a new data set I'm making. Less than hyphen means make a new file based on the old data set I had. This little bit is sampling the 500 observations and not sampling with replacement. It was just going to take at random that many observations for me. I can hit the run button on that and it runs that. Now I can make a simple plot. So I can take my little sample that I can plot, just as before we're using the jitter command to jitter both the X and the Y axes here. You can run that. That generates the following plot. Okay, this gives me some idea. It looks vaguely similar to figure 8.3 in the Morling book. We have negative skew. We have scatters at points around here. Maybe it's the case that I don't want to see jitter my sample meet 1. I might want to put some labels on that. Well, line 7 has a comment. Let's change, sorry. Oops, I want to change the plot symbol to something else first. So that's done by adding a single line that says the plot character, PCH, is now some other number. And that gives me a slightly different value. Okay, so this next example, I can make a plot, and maybe I want to change the plot symbol a little bit. Instead of the number 1, instead of the default value, which was a circle, I might want to look at squares. And I do that with the plot character statement, PCH. I had a comma, add that in. After running that, I now see I have squares. Maybe I actually want to have some labels rather than these things which talk about the values that I have in terms of the code I have. Well, I'm going to have the plot statement, same old jitter statement. Maybe I'll go back to my circles, 21 instead of 22. And I'll add this line in, X label and Y label. And that will give me some text that will actually tell me what my labels are. Now, we talked in class about the fact that you have sometimes seen box plots. Those are also fairly easy to do inside of R as well. Here's some code for doing that. I say box plot, satisfaction, the Y variable, tilde meet the X variable, the name of my data set. Maybe I want to put a label on all of my plot, and I want to label the X value, the X variable and the Y variable. And here you see a general label and a label here and a label here. This isn't the prettiest plot because those boxes are fairly wide. And there are other options I can use where I can make it narrower, make it look a little prettier. In addition to In addition to box plots, there are other options out there that you can look at, like violin plots. And I think I'll just show them to you and then explain why they might be a little bit cooler or maybe a little more aesthetically pleasing. In order to get violin plots, you'll have to install the VioPlot app. So going up here under Tools, you'll hit Install Packages and then type in VioPlot for violin plot and hit the Install button. And RStudio Cloud will take its own sweet time installing that. When that's done, you tell R, hey, I want to use this thing that I installed. It's a library statement. And what we'll do here is we'll make a variable called online, which consists of the data set. This is the complete data set, not just my little sample. The satisfaction values for all times where meet is the number 1. And then I'll save the scores for offline based on the data set satisfaction for all the times where meet is 2. And we'll run those two things. And the VioPlot then has as its syntax the online scores, the offline scores. This names command gives me some labels for what these two groups are. The col colors my violin plots, and the Y label gives me the label for the Y-axis as I had before. And here we go. Now, violin plots are kind of nice. They're a bit similar to what are called stem and leaf plots. It'll show you the arithmetic mean. There are some other options where I can look at the median. And what you see here is a duplicate of the distribution of the scores. So you can kind of think of this as being chopped down the middle. This is actually a plot of the distribution. They just double it to make it look kind of nice. From this, you can see that this is a negatively skewed distribution, and that skew is further reflected in the box plot that's given here in the middle. And again, if I want to put a title on the whole thing, I can add a title statement and hit the Run button, and there I have that. Now let's talk about the second thing. I have a plot now, and it's in the cloud, and I want to have that go to my computer. As we talked about before, we can export this as a PDF, and then upstairs I can say, how big do I want this picture to be? Maybe 4 by 6 inches is enough when you're doing an article. And the orientation is landscape. It's going to be wide. And I might want to give it a name, for example, violin plots. And that's going to give me a file down here. And that PDF now exists in the cloud. And now what I want to do is to export that to my computer. So I want to click the violin plots, go over to the More button, come down here to export and select that. It says the selected file will be downloaded to my computer. Specify a name for the file. I want it to have the same name as it had. And this then downloaded my file. Here's where it is. It downloaded to my computer, my downloads folder. So now that I've exported this file, it downloads it. And where did it get sent to? Well, it got sent to my downloads file on my computer. Here we can see it. And if you double click on this, this now is on your PC. In other words, you can take that file and mail it to an instructor, to the other people working in your research team. I hope that helps. I hope this is enough of 2 more pieces that we can work on tomorrow.